Welcome to Spring LIB.
Continuing on with electrochemistry, we're essentially looking at how electrons move throughout our system. So we have several different electrode reactions. So the first, where we have IrCl63-, we have an E value of 0.77, PtCl42-, 0.73 volts, PdCl42-, 0.62 volts, where we add a series of electrons, add 3 electrons, add 2 electrons, add 2 electrons to generate our products. So we can use our Nernst equation here to determine the E cell for all 3 metals at specific concentrations, where the E cell equals E0, subtract 0.0592 divided by N multiplied by log of the Q, where Q is essentially the concentration of the products divided by the concentration of our reactants. So for the first example, we'll do it in 4-foot iridium metal with a concentration of 0.02 molars. We have E cell equal to E0, subtract 0.0592 divided by N log of IR multiplied by Cl minus to the power 6 because of the stoichiometric coefficients, IrCl63 minus. We get a value of 0.74 when we plug in 3 molar here and 0.77 volts here. So that's for the first one. We then have the second and the third. So then what we can take a look at is plugging in a different concentration for IrCl6. So when we have 0.00020 molar for IrCl63-, we have 0.7 volts. And therefore 99% of iridium will plate out over the voltage range of 0.74 volts to 0.7 volts. So then for the next example, so we'll look at the second one using the same equation, and so when we have 0.020 for PtCl42-, we have a voltage of 0.68. And when we have 0.00020 PtCl42-, we have 0.62 volts. So 99% of platinum will plate out for the voltage range of 0.68 to 0.62 volts. Final example, we have 0.020 PdCl42-, 0.57 volts. 0.00020 PdCl42-, 0.51 volts, and so 99% of palladium will plate out over the voltage range 0.57 to 0.51, and because they all have different potential ranges, they can be separated out by electrolysis.